Hello students, we are going to start today the optics, the geometrical optics. So first of all we will try to understand the meaning of optics and then we will continue our discussion in the optics, that is the geometrical optics. So let us try to understand what is optics. In optics basically here the light is required and eye is required. So light and eye, so we can say a study of light and vision. Optics is basically the study of light and vision. When we try to understand the optics, you have read it in junior classes also. The optics study we do under two headings. One portion is called geometrical optics. It is also called your ray optics. And the other portion is called your physical optics. This optics gives the answer to the question, what is light? So this gives the answer to the question, what is light? And this gives you the answer to the question, what light does? When we talk about physical optics, then in physical optics it is further divided into two groups. Some considered light as wave, then it comes wave optics. When light is considered as wave, and when it is treated as particle, then it is called quantum optics. And some scientists treat it as both. So here comes the dual nature. Here comes the dual nature of light. So basically we will have to concentrate on this geometrical optics. This geometrical optics is very important, and basically we have to concentrate on this geometrical optics. You can understand it in this way also, that this is basically your medical aspect. In a figurative sense I am saying it is the medical aspect, whereas this tells about the engineering portion. So what we can understand that study of light and vision can be broadly classified into two portions, geometrical optics and the physical optics. So let us start our discussion with geometrical optics. So we will continue our discussion with geometrical optics. In geometrical optics, the basic parameter that you have to keep in mind, that size of object or obstacle is very large as compared to wavelength of light. As compared to wavelength of light. Now the wavelength of light, this is a meter, this is a parameter that is associated with every color. In general, if we talk about the visible region, this wavelength from 3800 angstrom, angstrom is the unit of length, 10 to the power minus 10 meter is 1 angstrom, to 7800 angstrom. Approximately this is the region, and this tells about your violet and this tells about your red. Wavelength of red is nearly this one, and wavelength of violet is nearly 3800 angstrom. Roughly you can take 4000 angstrom to 8000 angstrom, roughly. So this thing, I hope that you have understood that in the background of, before beginning the optics, you should understand this much amount of matter for a clear understanding of the subject matter. This is the prerequisite to start the optics. Now I will start your geometrical optics in detail. The study of geometrical optics begins with the discussion of reflection. You have read in your junior classes that what is reflection? Reflection is basically the bouncing back of light into the same medium. The phenomenon is known as reflection. This study of reflection is also done under two headings. First heading is your plane surface. That is, I am talking about plane mirror. The second portion will be a spherical surface. And in this you already understand concave and convex mirror will come. So study of reflection, that is bouncing back of light, we will be discussing under two headings. One is plane surface, that is plane mirror, and one is a spherical surface, that is a spherical mirror, which is of two types, concave and convex, that you already know. Now in general you should understand that if the plane mirror is here, which I consider as XY, and this is the incident ray AO. O is the point of incidence, and this is the reflected ray OB, and here I am taking the normal, and this is the angle of incidence I, this is the angle of reflection R, and in this direction if we will move, then this angle tells about the angle of deviation delta, and this delta is basically your, you see here total 180 is there, so delta is basically your 180 minus 2I, or this can be 180 minus 2R. Why? I is equal to R, which is the law of reflection. I, angle of incidence, is equals to R, angle of reflection, which is the law of reflection. Law of reflection also suggests that incident ray, reflected ray and normal lie in the same plane. What does it mean? If we consider with this red marker that it is the incident ray and it is the reflected ray, then this should be the normal. All are lying into the plane of board. If I will take this thing as the normal, this is not possible because this is perpendicular to the plane of board. So this can be incident ray, this can be reflected ray, and this is the normal. This cannot be normal because it is not in the plane of incident ray and reflected ray. So you all should understand very carefully that the law of reflection suggests that incident ray, reflected ray and normal lie in the same plane, and angle of incidence is equals to angle of reflection. Now very simple question, you can understand that if I take R is equals to 30 degree, then what is the value of delta? Delta will be, very simply you can understand, delta will be 180 minus 2 into 30, 60, so that is 120 degree. So if R is equals to 30 degree, this means I is equals to 30 degree, and this angle is called basically your glancing angle G. So if R is equals to 30 degree, I is equals to 30 degree by the law of reflection, and if this is 30 degree, G will be equals to 60 degree. This is your 30 degree and this will be your 60 degree, and your glancing angle is 120 degree. So this thing should be clearly understood into mind, and these are very simple things that you already know from your previous knowledge, that is from the junior classes. You know these things, so I am not putting a stress on these things. I will be moving to some other concepts. So this should be clearly kept into your mind. When you will see the discussion of plane mirror in your book, you will find that 1 or 2 pages are sufficient enough to explain the concept of plane mirror. But The questions based on plane mirror are very important and they need proper attention for solving them, not only in your board examination but also in your entrance examination. So in entrance examination, many types of questions, varieties of questions can be framed keeping the concept of plane mirror in mind. So let us now try to understand in that process. Let us try to understand the concept in this way. Suppose I am writing a equation y is equals to mx plus c. When I am writing this equation y is equals to mx plus c, naturally y is the function of x and it is equation of a straight line. It is equation of a straight line. Here m is equals to dy by dx, that is your tan theta, that is your slope, and c is the intercept on y-axis. C is the intercept on y-axis. This thing you should know from mathematics, knowledge of mathematics, you can know this thing that this is the equation of a straight line. Now compare this equation, with this equation that I am writing here. So if I write it in this way, delta is equals to minus 2i plus 180 degree. This is in the place of y, this is in the place of m, this is in the place of x, and this is in the place of c. Now let us try to analyze the graph between delta and I. As here it is a straight line, so this will also represent a straight line. In this case, that is in the case of your plane mirror. So if I want to analyze the graph, see carefully. Here I am taking the y-axis on which I am taking the deviation delta, and on x-axis I am taking the angle of incidence I. If the value of I is 0, then delta is equals to 180. So if the value of I is 0, delta is equals to 180. So suppose we are getting a point here where the value of I is 0 and delta is your 180 degree. Suppose one point is this. If I take delta is equals to 0, then I will be 90 degree. So if I take delta is equals to 0, then here you see on this y-axis, here x-axis, the delta is 0, and when delta is 0, what is the value of I? I is equals to 90 degrees. Suppose it is your 90 degree. So this point is giving you 90 degree and 0. If we join these two lines, this is representing the equation, this is representing the curve which is a straight line with negative slope. Why? Here you see, here the value of theta is greater than 90. That means tan theta is negative. That means slope is negative. So the graph between delta and I in case of plane mirror is a straight line with negative slope. The graph between delta and I in case of plane mirror is a straight line with negative slope. This point you all should remember very carefully all the time. All the time you should remember this point very carefully, that the graph between delta and I is a straight line with negative slope, not with positive slope, with negative slope. And this will, I hope that this discussion will clarify your concept on the plane mirror. Now, what I would like to tell you, I am talking about reflection, and this reflection is reflection at plane surface. Here xy is your plane mirror. Now, what I would like to tell you, this point has a special meaning and this point has a special meaning. These 2 points represent some special situation. What are those situations that I would like to discuss with you? This is basically representing your normal incidence, and this is basically representing your grazing incidence. Now try to understand two new words you have learned. One is the normal incidence and one is the grazing incidence. Grazing is a word of English. Cow grazes in the field. So that grazing incidence is there. Now I will explain the meaning of this thing that you should understand. And this becomes the part of question that in normal incidence, I is equals to how much? Whether it is 0, 80, 180, 90, something like this. Or in grazing incidence, I is equals to how much? 0, 180, something like this. So here also you should think one thing, that angle of incidence has the value always between 0 and 90. The angle of incidence will always have the value between 0 and 90, including 0 and including 90. So angle of incidence, 0 is less than equals to I and I is less than equals to 90. So angle of incidence should always be remembered that its value cannot exceed this limit. And so R is also there. Now I would like to discuss with you the grazing incidence in detail. Grazing incidence and grazing emergence. But before that, I would like to tell you that here, if we consider it as air, here also it is air. So light is coming back into the same medium after reflection. Bouncing back of light into the same medium is called your reflection. If here the speed is 3 into 10 to the power 8 meter per second, here also the speed is 3 into 10 to the power 8 meter per second. So by the knowledge of vectors, you might be understanding that speed of light has not changed in reflection, but velocity has changed. Why? Because the direction has changed. So the speed of light does not change in the process of reflection, but velocity changes because the direction changes. This thing also I would like to write as an important point. So you all should understand very carefully that the speed of light does not change during the reflection, but its velocity changes due to change in direction. You see, here the direction of speed is this, here the direction of speed is this. So the velocity has changed because velocity has this direction and here the velocity has this direction. This thing you should see and understand very carefully about the reflection of light. Now what I would like to discuss, I will tell you, I will try to make you understand the normal incidence and the grazing incidence. So we have to understand the normal incidence and grazing incidence. Now what I would like to tell you, if I am taking for your understanding that there is this type of surface, I am taking this type of surface and this is the point of incidence, then this tells about your incident ray and this tells about your reflected ray. If we drop the normal here, then this is the angle of incidence, I is equals to 90 degree. As the ray has not deviated, whatever is the direction of incident ray, same is the direction of reflected ray, therefore deviation is equals to 0. If the incident ray deviates in this direction, then also the deviation is there. If the incident ray deviates in this direction, then also the deviation is there. But here what we observe, that whatever is the direction of incident ray is the same direction of reflected ray, and therefore the deviation is 0. And this situation is called your grazing incidence. Grazing incidence. In plane mirror, I have used here curved mirror for your understanding only, but if you will take the plane mirror also, then also the same situation will take place, that if the ray of light is incident in this way, then it is going in this way. It is grazing on the surface. And here, if you will take the normal, this I is equals to 90 degree. And this is the incident ray, and this is your reflected ray. And this tells about reflecting surface. So this tells you the grazing incidence. What next I would like to tell you? I would like to tell you that in case of normal incidence, for normal incidence, here you see, if I take as the reflecting surface and a ray of light is incident in this way. Now what is the angle of incidence? Generally the student get confused and they say that the angle of incidence is 90 degree. But here the angle of incidence is not 90 degree, it is 0 degree. Why? Here you see, if this is the reflecting surface and this is the normal, here you see, suppose this angle is 45 degree. So this angle is 45 degree, so incident ray making with normal, if I move it in this direction, suppose it is 5 degree. And if I make it in this way, then it is your 0 degree. See how it is moving. When the ray is incident along the normal, then angle of incidence is 0. Here it is 45, here it is 5, and here when it is along normally incident, then the angle of incidence is 0. So when angle of incidence is 0, angle of reflection is also 0. The ray, this is the incident ray, this is the reflected ray. And what we call? We call the direction incident to reflected. You might be remembering. Incident ray direction to reflected ray, this is your deviation. So incident ray direction to reflected ray, this is your deviation, delta, and that is equals to 180 degree. And what is the angle of incidence? Angle of incidence is 0 degree. And what is this name? Its name is normal incidence. So you have understood what is normal incidence, what is grazing incidence, how in case of grazing incidence, what is the value of I, what is the value of delta. In case of normal incidence, what is the value of I, what is the value of delta. So I hope that this much of discussion on the plane mirror section will certainly be helpful to you in understanding the subject matter of geometrical optics, that is ray optics, in a better way. You all should keep it in mind that when I am talking about ray, it is basically the direction of flow of light energy. Light energy flows along this line. So ray optics is called geometrical optics also because its rules are based, its phenomena are explained keeping the geometry of a straight line. So a straight line path light ray follows, that matter is the base of your geometrical optics, and therefore ray optics or geometrical optics are same, and ray optics is called your geometrical optics. This much amount of discussion you should keep in mind, and in next class I will be discussing some questions based on the deviation concept and related good interesting questions that will certainly give you a better understanding of the concept of deviation in case of plane mirror. Thank you. Have a nice day. Ray optics is geometrical optics. So basically questions are framed to test the knowledge of geometry that you have read in your junior classes, that is in your 8th, 9th classes. Let us try to understand by the example. Let us take one illustration. Suppose you have the already idea of geometry from your junior classes and you know from the optics that I is equals to R. Let us suppose that there is a plane mirror and this angle is theta that you have to find. This line is horizontal. Here is the incident ray. This is the reflected ray and it is vertical. You have to tell the value of theta. Think about it for a few minutes and then we will talk about the solution. So in this question, if you are trying to understand, see, if this is horizontal, this angle is theta, so this angle is also theta. Here one more thing is given, that this angle is your, suppose 20 degree. So this angle is theta. Now one concept you have to understand, that in case of plane mirror, if this is the incident ray, this is the reflected ray, this is the normal, if this angle is x, this angle is also x, I is equals to r, and if this angle is theta, this angle is also theta. That means incident ray making with the reflecting surface, same angle is made by reflected ray with the reflecting surface. These two angles are equal. So here what we can see, this is the incident ray and this is making with the reflecting surface the angle theta plus 20 degree. This angle is 20 and this is horizontal, this is vertical, so this angle is 90 minus 20, that is 70 degree. Incident ray making with the reflecting surface theta plus 20. So reflected ray making with the reflecting surface is also your theta plus 20. Now apply the straight angle rule and you will get the value of theta. That means theta plus 20 plus 70 plus theta plus 20 is equals to 180 degree. And if you will calculate, you will get 2 theta 180 minus 110 degree, that is your 70 degree. So theta is equals to 35 degree. This should be your answer. Similar profile question I will give you, and that you will try and test that what you have understood in this question. For that, what I will tell you, I will just make this incident ray below the horizontal line by the same angle 20 degree, and you will have to find the same question, theta is equals to how much. Let us see what the question says. Same question, the plane mirror is there, this angle is your theta, this is horizontal, but this time the incident ray is below the horizontal line. This is your incident ray, and again this angle is 20 degree, and then the reflected ray becomes vertical, and you have to find the value of theta. Think for a moment, attempt this question and then see the solution. This time this is the incident ray. If this is making an angle x, then reflected ray also makes the angle x, as I told you, and this is horizontal, this is vertical, so this angle is 90 degree. So if we take the straight angle concept, you see x plus 20 degree plus 90 degree plus x is equals to 180 degree. So what we are getting, 2x plus 110, 180 degree. So we are getting x is equals to 35 degree. Can we say x is equals to theta? No. Theta is basically the alternate angle x plus 20. Therefore, theta is equals to x plus 20, that is 35 plus 20, that is your 55 degree. This should be your answer. So in these questions, what we observe that this is the question of optics, but basically it tests the knowledge of your geometry, and that geometry which you have read in your junior classes, that is 8th, 9th, 10th. Let us do one more question that is based on geometry. Here, two plane mirrors are inclined at 70 degree. A ray of light is incident. After reflection it falls on the other mirror and it becomes parallel to mirror M1. This is M1. It is parallel to. This ray is not parallel. This is parallel. Now they are asking, this is normal. This angle of incidence I is equals to how much? Think about this question. This is also based on geometry. And in this question, you will observe that this angle is 70 degrees. So this angle is also 70 degree. Why? Because it is corresponding angle. So this is your 70 degree. If I drop a normal, this angle should be 20 degree. This angle should also be 20 degree. I is equals to R. So this angle should be equals to 70 degree. If we are taking this as the 70 degree and this as the 70 degree, naturally this sum of the angle is 180 degree, so it should be equals to 40 degree. If it is 40 degree, this is normal, this should be equals to 50 degree. And the value of I we are getting as 50 degree. This should be your answer. Value of I should be 50 degree. Two plane mirrors are there. Now we will try to see few examples based on deviation that we have learned. Delta is equals to 180 degree minus 2i. On this formula, we will try to see that how this formula can be applied in order to solve few questions in finding the value of deviation. So let us consider there are two mirrors and the angle between the mirrors is 60 degree. A ray of light parallel to the mirror M2 is incident here. This is parallel to M2. And the question is, find net deviation after two successive. Now first you have to complete the diagram. This diagram is incomplete and question is given in this way. So first you will have to complete the diagram. How can we complete the diagram? Here we will draw the normal and this will represent your reflected ray. Here again we will drop the normal and this will represent your reflected ray. So there are two reflections. First reflection is taking place here and second reflection is taking place here. If we see the incident ray direction, this gives you the first reflection delta 1. If you see the incident ray here, this gives you the second reflection delta 2. What I would like to tell you, this is anti-clockwise. This is also anti-clockwise. So if we calculate delta net, both have same direction, so we can add delta 1 plus delta 2. Now our main intention is to find delta 1, for which we need this angle. As you understand, this is 60, so this should also be 60. This should be 30. This should be 30. Now you see carefully. If delta 1 is equals to 180 minus 2i, 180 minus 2 into 30, that is 120 degree anti-clockwise. This is 30, so this angle must be equals to 60. So this angle should also be equals to 60. Then here also it is 30. and this is also your 30. So if you will observe delta 2 is equals to 180 minus 2 into 30, and this is giving you 180 minus 60, that is 120 degree anti-clockwise. Now we can get the value of delta 1 plus delta 2. This will be 240 degree anti-clockwise. This should be your answer. So in this way we calculate the value of net deviations. If there are 2 deviations, we will add delta 1 plus delta 2. If there are 3 deviations, we will add delta 1 plus delta 2 plus delta 3. Like that only we can do in this way. Let us do one more question based on the deviation. Question remains the same, find the net deviation, but this time the arrangement of mirror is in this way. Again the ray is parallel to horizontal, and you will have to find the net deviation after 2 reflections. This is vertical, this is horizontal. Now in this case again you will have to complete the diagram. So how we will complete the diagram? This is the reflected ray. Here it is first reflection. This is the reflected ray. Here it is the second reflection. This is mirror M1. This is mirror M2. Now here you see, here the deviation delta 1 anti-clockwise, and here you see the deviation delta 2. This is your clockwise. So what will be the result? Delta net in this case will be delta 1 minus delta 2, because one is clockwise, one is anti-clockwise, one is clockwise. Now this angle is 60, so this angle is also 60. So this angle is 30. This angle is also 30. This is 60, so this is also 60, alternate angle. So this is also 60, alternate angle. Now what I would like to tell you, delta 1, 180 minus 2i. This is giving you 180 minus 2 into 30, 120 degree anti-clockwise. First deviation is 120 degree anti-clockwise, incident ray anti-clockwise, and delta 2 180 minus 2 into 60 degree clockwise. See, this is in this direction. If you see a clock, this direction is your clockwise and this direction is your anti-clockwise. See, this is clockwise, this is anti-clockwise. You see, this has got this direction, this has got this direction. So what is delta net? Delta net we are getting 120 minus 60, that is 60 degree anti-clockwise. Hope with this much discussion of reflection at plane surface, some better concept and understanding might have been taken place in you for development of the understanding of optics. One more lecture I will be taking on the plane surface, and then the plane surface will be completed. This lecture is based on the fact that it will give you the totality of concept. What is that totality of concept? It will give you both the board examination preparation and it will give you the entrance examination requirement. It will fulfill your entrance examination requirement also. So at the same time, if both preparation takes place with you, then it will be an additional advantage for you people. Just try to understand, in the derivation section, that is the part of your board examination generally, and the application section of the formula and concept, that is the part of your entrance examination. So if derivation portion and application portion both are done simultaneously, certainly it will be an additional advantage for you people, and you will be feeling better and comfortable while facing the board examination or entrance examination, and your confidence level will be high, so that the chances of doing mistake will be minimum. Thank you. We will be meeting in our next lecture.